All right, so I'm going to be doing a series of videos where I'm going to analyze a bunch of elastic collisions. I've done this before in the past, but I think it's necessary to do it again, mainly because the opposition believes or claims that there's absolutely not a single piece of valid evidence that proves the existence of kinetic energy. So what I'm going to be doing, in the past, I've done analysis videos on elastic collisions, but mainly only where we have a collision of a one mass colliding into a two mass, so a 1-to-2 mass ratio. But now I'm going to be doing a lot more, many more different types of mass ratios. So over here you can see this equation. Okay, this is the exact same equation that Walter Lewin used in his famous lecture to predict the outcome of a 1-to-2 mass ratio. And so the outcome was that the mass 2 velocity will be 2/3 of the initial velocity, and the one mass car will produce 1/3 the velocity in opposite direction. That's what this equation predicted. So now I will use this equation and predict the outcomes of many elastic collision videos that you find on YouTube. And what you will see is that they will match the result. So my question is, if this formula predicts 2/3 and 1/3 for a 1-to-2 mass ratio, if that's wrong, if that can't possibly happen, if that's an example of kinetic energy, then is this also incorrect for another type of mass ratio? So I'm going to be analyzing this particular experiment, elastic collision experiment, for today. And first, so what he's going to do is going to measure the weights. That's going to be our mass ratio. So let's see.
All right, this is a tougher experiment now. I'm going to get the masses of the cartons.
So this is going to be the mass 1, which is 411.9 gram. So I'm going to add the data. So mass 1 is going to be we got to convert it into kilograms, 0.4119 kilograms. That's going to be our mass 1.
412-ish. 1.
Here we have 209.7. So mass 2 will be 0.297 kilograms. So as we can see, we have a heavy mass colliding into a small mass, pretty much 2-to-1 ratio. So now for the opposition, what would your prediction be in an ideal situation? So for a 1-to-2 mass, we know that for the opposition, okay, that the 2 mass can't possibly come out faster than half the velocity. So what will happen for a 2-to-1 mass ratio? For my understanding, I would assume that it would be the opposite. The one mass should be at least going at least twice as fast. But anyway, if you don't provide an equation, I cannot test it, cannot predict it. So I'm asking you, what is your prediction for a 1-to-2 mass ratio?
The idea, when I put this up here, actually a little bit balancing. Be careful. You got to watch the times of the.
All right, so we got photo gates. This one has a red tape. This one has a blue tape. And he put it on the screen as well. Red tape, so this one is this velocity. The blue tape, this one is this velocity. Then the purple tape, I don't know. I think it's like the difference. That's not really important. All we need is a red tape and a blue tape.
If this is the red timer, blue timer, and this is the time between. I don't know where you're going to need all those or not. I don't have time to think. Okay. So I'm going to run this and watch out for the video. Both of them should end up going through this.
Replace myself here.
You're going to see 2 different times on the blue. You're going to have to perform both of those.
Okay, so he forgot to zero the times. So
Oh, I didn't have time to go through. All right, one more try, keep it rolling.
The reset button on the timers.
Yeah, to reset. Okay.
Okay, let's try that again. My apologies for really interrupting.
Oh, reset again.
Thank you. Here we go.
All right, so now it went through the first gate, and we have the timings 0.18, 10 seconds. So we can write down T1 equals 0.18, 10 seconds, right? I replace myself again. All right, so second time for the second card, 1425. T2 T2 equals 0.1425. And then the first card, which was a bigger mass, will continue moving in the same direction. So let's see what, so it will go through the second gate. So let's see what that timing is.
Stop this one.
All right, so we have 5281. That's T1 prime. T1 prime. 52, what was it? 5281 seconds. All right, so now we have our data. These are the experimental results. Now we're going to do our predictions using this equation. All right, so we got, so this is to calculate the velocity, the first velocity of the first mass, so the heavy mass after a collision. So, which is going to be T1 prime. These are the results. Now we're going to do the prediction for T1 prime. All right, so let's do. So it's going to take a while. So mass 1 for 0.19 minus mass 2 0.2097. Yeah, I should add the units, but whatever. You know what I'm doing. Divided by M1 plus M2. So M1, so now again 0.4119 plus 0.2097. All right, this. Then we have to times it, times the initial velocity. Oh yeah, I forgot to turn it into velocity. So the timings, we have to, in order to calculate the velocity, we have to do distance divided by time. We need to know the length of the cards. Now, it doesn't really matter whether the lengths are 5 centimeters or 10 centimeters. If we, if they were 5 centimeters and we divide 5 over all these timings, or we take 10 centimeters as the length and we divide it over all these timings, the ratios will be the same. So let's take 10 centimeters as the length of the card, because we don't know what the lengths are. It didn't measure it. So let me just quickly calculate it on my phone. So let's say 10 centimeters, which is 0.1 meters, divided by T1, which is 0.1810. It's going to be, so equals 0.5524 meters per second. Oops. Then T2, which is 0.1 divided by 0.1425, which is going to be 0.7017 meters per second. Then T1 prime, 0.1 divided by 0.5281, which is going to be 0.1893 meters per second. So now we got our velocities. All right. And then so times the V1 initial, which is 0.55, so times 0.5514 meters per second, or just, yeah. All right, so 0.4119 minus 0.2097 equals 0.2020. Divided by 0.4119 plus 0.2097 equals 0.6216. All right, let's do that. So 0.20, 22 divided by 0.6216, all right, times 0.5524 equals 0.1796 meters per second. This is the prediction for cart 1 after collision. So the heavy cart, when it after collision, it will continue to go through the second photo gate. All right. So the prediction was 0.1796 meters per second, and the result was, so T1 prime, the result is 0.1893 meters per second. Right. So this is close, really close. It's almost 0.18 meters per second. The result is 0.1893, so almost 0.19. It's one off. It's one off. So I would say a pretty good match. All right, that's T1 prime. So let me, hold on. So now we got to calculate T2 prime. So let's put that one over here. T2 prime. I mean, yeah, T2, just T2, the second velocity. So hang on a bit. To 2 times mass 1, 2 times mass 1. Bear with me. Just showing you step by step. So 2 times mass 1 divided by mass 1 plus mass 2, so 0.49 plus m2 0.2097, okay. Times the initial velocity, times the initial velocity of, and then plus this, but since the initial velocity of mass 2 was 0, this whole thing becomes 0, so we can just skip this, and we just have to look at this one. All right, so equals, so 2 times 0.4119 equals 0.82838 divided by, so again, 0.4119 plus 0.2097, yes, 0.62, all right, we go, times 5524. All right, so equals point, almost there, 0.8238 divided by 0.6216 times 0.5524 equals, there we go, equals 0.7320 meters per second. This is the prediction for the second mass after collision. So as you can see, it's 0.7320 meters per second is the prediction, and the result is 0.7017 meters per second. It's a little bit more far off than the prediction and the result for the first mass, but still pretty close. 73 versus 70 meters per second, 3 off. Okay, I would still say pretty good match. So again, if this equation, the very equation that predicts the 2/3 outcome and a 1/3 outcome for a 1-to-2 mass ratio, if that can't possibly be true, then my question is, this very experiment where we have a 1 mass, where we have 412 grams colliding into 209 grams, this type of mass ratio, and these predictions versus the results, then I assume that this also can be correct, as for 1-to-2 mass ratio, 2/3, 1/3, that can possibly be true. And then I guess this equation cannot work for any type of mass ratio. But significantly, the results are pretty damn close. I mean, the predictions are pretty damn close to the results. All right, so this is the first analysis of an elastic collision experiment, and I will do many more since there exist many elastic collisions of various mass ratios on YouTube. Okay, so thank you all for watching, and I'll see you in the next video. And stop recording.